implementing a backup strategy. So backups are extremely important and incredibly useful. The big one being extremely important, obviously, because if something were to happen to our database, accidental or malicious, we need a way to restore it back to the state that it was prior to that event happening. So in this nugget, we're going to look at the factors that will help us determine what backup strategy to use, and then we'll put a few of these strategies to use over in the Virtual Nugget Lab to see them in action. Checking out our Nugget overview, we're going to start here with backup types and strategies. Get a whiteboard going here on all the different backup types available to us. Talk about your full backups, your differential backups, your transaction log backups. We'll even touch on file group backups, and copy-only backups. So really all the different backup types in SQL Server, and then how they can work together to come up with a strategy. I'll even touch on the recovery models because those are going to directly affect the strategy that we use here for backing up our databases. Then we'll jump over to the Virtual Nugget Lab and get familiar with how to back up databases. We'll put one of those strategies to use. I'll show you how to do point-in-time recovery by utilizing all three of the major backup types, full, differential, and transaction log backups, all working together within our strategy. From there, we'll take a look at some backup options. I'll show you how to utilize backup compression. We'll talk about devices and media sets and any other options we can find in there we'll cover. Then at the end, we'll take a look at how to work with backups and deal with very large databases. So we'll look at file and file group backups to ease the pain of backing up those terabyte databases. And we'll also talk about copy-only backups, and I'll show you what copy-only backups are all about through example. And I'll tell you, they'll help keep the peace between your DBAs and your developers. When those developers just love to just go and back up a database, if you have a differential backup strategy or transaction log backup strategy, those developers can really ruin your day if they just take a backup and ruin your chain and your sequences. So we'll touch on it when we get there, but copy-only backups will help alleviate a lot of those stresses. So checking out our backup types and strategies, let's start with all the different types available to us. So the big ones are going to be your full, differential, and transaction log. Your full backup is a lot like just doing a copy-paste in Windows. You're copying the backup at that point in time, and it's going to include everything, data, the objects, all the way up to the time where the backup completes. So when the backup is done is your snapshot, your copy of a database. The downside with full backups is that because they include absolutely everything, they're going to take the longest. So on a very large database, a full backup could take hours and hours and hours. So doing a full backup every night isn't going to cut it. So that's where differentials come into play. Differential backups allow us to take a snapshot of all the data that has changed since the last full backup. And I do want to mention that differentials are cumulative. So if you do multiple differential backups, they're going to include the changes that have occurred in the previous differential. So for instance, if we do a full backup, an hour later we do a differential backup, that's only going to have the changes since the last full. And then another hour later we do another differential. Differential 2 is going to contain all the changes that differential 1 has, and then anything that's happened in between differential 1 and differential 2. And we'll see this as an example when we get over to the Virtual Nugget Lab. So while differential backups can alleviate a lot of the size issues that we could have with doing full backups, they over time they degrade because they get bigger and bigger as well. So that's where transaction log backups come into play. So transaction log backups include all the data that's modified since the last full differential or transaction log backup, and these are not cumulative because every time a transaction log backup occurs, it truncates the log, which gets rid of all the inactive or old transactions inside of it that have been committed to the database. So transaction log backups also give us point-in-time recovery, which is crucial to those databases that do not have an acceptable level of data loss. More on that in a minute, but the transaction log, really what it is, if I haven't mentioned this before, is really just a log of all the transactions that have occurred since the last truncation, since the last time the log was empty. So really, it's all anytime a transaction modifies data, it's recorded first in the log, and then when SQL Server gets around to actually physically writing that data that transaction affected across all the data pages, then that entry in the log will be marked as inactive, and the next time a truncation occurs, it'll get rid of that record. So the only things that'll truncate a log automatically are transaction log backups. Now, the reason I'm saying all this is because of the recovery model. The recovery model you use really affects the transaction log because the simple recovery model really means that you're not going to be able to do point-in-time recovery because SQL Server is going to truncate that log on checkpoint. And the checkpoint happens by default every minute, where it's just going to erase the inactive portion of the log anytime a checkpoint occurs. The other side of that coin is the full recovery model, and this is really just us telling SQL Server to leave the transaction log alone. We're putting that onus on our shoulders to ensure that the transaction log is emptied. And really, the moral of the story is if you have your database set to full recovery mode, then you should be doing transaction log backups. If you don't, eventually that transaction log is going to fill up and get to that point where it's full, and then you'll have other issues on your hand. And you wouldn't believe how many people get into that problem because full was the default on the server, so their database was set in full, and the transaction log filled up, and now they're getting errors all over the place, and the database is inaccessible. So keep that one in mind because that's a pretty common thing to happen. Just understand if you're in simple mode, SQL Server is going to manage the size of the transaction log, but you won't be able to do point-in-time recovery. Full, we're going to manage that transaction log, hopefully by doing transaction log backups, and we will get point-in-time recovery. Oh, and by the way, the bulk logged recovery model is really for when you're going to do a bulk logged operation, you want to minimize the amount of logging when you're doing that operation. But keep in mind, you also won't be able to do point-in-time recovery with bulk log because it doesn't log enough information for us to do so. So the last piece of the puzzle we need to determine our backup strategy is going to be knowing our environment and knowing our data and the type of database that we're working with. As we mentioned here with data loss, is there an acceptable level of data loss in time frame? Is it going to be a day, an hour, 5 minutes, 10 minutes? What is that acceptable window? Because if it's a day, you could probably get away with full backups and differential backups. On the other hand, if it's an hour or minutes, then you're probably going to need to employ something with transaction log backups in it. The type of database, another big one here that's going to help us come up with a backup strategy. If we have a database that has a lot of action in it, it has data that has a very low amount of acceptable data loss, then we could do something like this. We could do once a day, maybe once a night we do a full backup. Once an hour we could do a differential, and then say every 10 minutes we could do a transaction log backup. That would be a good strategy for something of small to medium size where we could use point-in-time recovery where acceptable data loss was around 10 minutes. So the size of our database is another important factor, and just using the same scenario, let's say that we have a similar database to this one, just that it's way bigger. Well, we wouldn't be able to do this kind of scenario here, at least at this upper level. So what we could do is we could say we want full backups once a week, differentials maybe twice a day, and transaction logs maybe once an hour, depending on, again, our acceptable level of data loss. Now, another strategy you can employ within this for those extremely large databases, which we'll take a look at how to do over in the Virtual Nugget Lab, is implement a file group backup strategy. And think of this as just splitting your database up, because now what we can do, and a great strategy here, is a lot of large databases have a lot of read-only data, a lot of archived data, and that's the reason they're so big. People don't like to delete anything these days. So what we could do is we could take all of our tables with that data that doesn't change very often, put it in its own file group, and then we could back up that file group maybe once a month. And then we could take our file group with a lot of action on it and put its own strategy on top of it that maybe does it, once a week, back to differentials again, maybe once or twice a day, and then transaction logs every 10 minutes or so. So that'll give us the best of both worlds where we don't have to worry about backing up that large data set that doesn't change very often, on a daily or even weekly basis. We can push it off to a monthly basis. And then we could do, differentials on that maybe once a week or once every couple of days. So it's kind of neat that using file groups, we can take our database, split it up, and then use our own backup strategies within those file groups. Another big factor here is going to be restoration time, and this is going to be more of a factor for those businesses that do not invest or implement a high availability solution like database mirroring or always on availability groups. Because if something goes wrong in the middle of the day, they're going to be scrambling to get a database back online from a backup. Now, when it comes to backing up, transaction logs take the least amount of time, as we said, and full backups take the most amount of time. Now, restoring is usually the opposite of that, where full backups take the least amount of time to restore, and transaction logs take the most amount of time. And this is really going to depend on your interval, but transaction logs take a long time because it has to apply roll forward or roll backward any changes in the transaction log, so it has to do it statement by statement, where full backups are essentially just a copy and paste. While we're on the topic of restoration, I want to just run through a quick restore and how that process works. Now, we do have an entire nugget dedicated to restoring databases, so I won't get into great detail, but I do want to complete the picture here. And more importantly, I want to get you familiar with the log chain, and there's even a differential chain, just so we can understand why the copy-only backup exists. So if we lost the database in the middle of the day and we needed to restore it, the first thing we would do is find our most recent full backup and restore it. Then if we have any differentials, we would find our most recent differential backup and restore it. Then we would restore our transaction logs in sequence. Because if these transaction logs are firing every 10 minutes, we're going to have a lot of them. And so what we need to do, and besides, every time we run a transaction log backup, it truncates the log. So we need all of these logs to reconstruct all of that time. So this is known as the log chain, and it's really just a sequence of transaction log backups. And remember, anytime a transaction log occurs, the current log gets truncated. So that's why we need these, and we need to restore them in sequence. And if for whatever reason we ever lost a transaction log in the middle of a chain to corruption or for whatever reason, then we would only be able to restore up to the point where the chain was broken. Anything after that break becomes irrelevant. Now, differentials work similar in nature because how this works is differentials are always based on the last full backup. So what that means is if somebody comes along and does a full backup, like a developer, to restore a test database, and then they delete the full backup, all differentials going forward are relevant because they're going to be based on that full backup that was deleted. So this is where the copy-only backup option comes into play because copy-only just simply says, I'm not going to affect the sequence. So in that scenario, a copy-only backup wouldn't have broke anything because the original full backup would have been in place and the differentials would still be based on that full backup that's in our backup strategy, not the one that the developer came in and took the liberty to do it on their own and then deleted the full backup. When we get over to the Virtual Nugget Lab, I'll go through that exact scenario so you can see how it works in SQL Server. So why don't we head over to the Virtual Nugget Lab? We'll start by just getting familiar with how to do all the different backup types, fulls, differentials, transaction logs. We'll go through a simple basic strategy that uses all three of them. And then we'll get familiar with some options. We'll take a look then at how to do a more complex backup strategy by using files and file groups on a large database. And then at the end, we'll get familiar with copy-only databases, how to do them. Again, get a strategy going, the one that we just looked at here. And then we'll also look at how to back up and what to back up as far as system databases go. Another important thing, your backup plan is never complete without taking your system databases into account. So here we are in the Virtual Nugget Lab, and I pre-launched SQL Server Management Studio down here, so we'll bring this up. I also opened up our solution for the series and took us right into the project for this nugget. We have a couple of scripts in here to work with. Let's open up our backups.sql script. I also have a connection through Object Explorer to our eval instance, and I want to show you how to do this manually through the interface first. And then I'll show you how to do it in Transact SQL, and then I'll even take you through how to set this up using the maintenance plan wizard so we can automate our entire strategy. But to keep things simple here to start, if you want to do this manually, just right-click on a database, head into Tasks, and into Backup. So the first screen here is just specifying what we want to back up. What's our source? And because we right-clicked on Nugget Demo DB, that's the default. You can choose all your databases here out of the list. You can choose your type, full, differential, transaction log. So full, we get all the options enabled for us. Differential, you cannot do copy-only backups in transaction log. You can't do database or files and file groups because it's a transaction log. So let's stick with full here to start. And copy only we'll talk about. We'll keep this simple and use database and files and file groups we'll also talk about here towards the end of this nugget. So right now it's just simply a full database backup. You can also give it the name. This is this current backup set describes just information about the backup. So you can give it a name, a description. If you want it to expire after a certain number of days on a specific date, you can do that. And also you can specify where you want it to go. So let's remove the default here and click on add. And it's going to default into the directory that we have set up as the default. You can control that default in the instance options. Let's hit the build button, browse up to our support files folder, and right into our backup folder. And let's give it the name nuggetdemodb underscore full.bak. There we go. We'll hit OK, and that'll let it in. Now you want to know something very interesting is if you want to do what's called a split file backup, you can add another file in here, and it'll actually write it, if it's especially if it's on another disk. You can get a huge performance boost here if this is we put, we could call this _1 and put it on the C drive, make one _2, put it on the D drive, another one _3, put it on the E drive. You get the point. And then it'll simultaneously write to all of those, and they'll all be split in thirds or halves if you do two of them. So that's a great way to spread them out for performance reasons. Another good one to think about if you have an extremely large database, you can get your disks working for you there. So that's really all there is to the first page. Specifying your source, give it some information, and then specify the destination. Then we have some options. So the first section here has to deal with media sets, a way that we can group our backups. So you can back up to an existing media set or create a brand new one. We have some reliability checks, some transaction log options we'll talk about when we do a transaction log backup. And if your device is a tape drive, then you have some options here, pretty straightforward. And finally here, backup compression. This is a good one. You can use the default server setting, which you can find in the instance properties database settings, or you can force it. We can force this, or we can explicitly tell it not to compress the backup. So let's leave the default there, which is we do not have compression turned on. It's not turned on by default, so you'll have to do that if you want to set that as the default setting. We'll leave everything the way it is here, and we'll hit OK, and that will give us a full backup. So that completed pretty quickly there. And if we want to see that full backup, let's just browse into our support files folder here and into our 13-backup, and there it is. You can see it's about 53 megs in size. So there it is. There's our full backup done. Pretty straightforward, pretty simple to do it manually. To do that in code, also very straightforward. Just backup database followed by the name of the database to disk, followed by the path. And then optionally here you can give it a name here. This is going to be the backup set name, the one that you saw on the first screen. So that's it. This little bit of code will do the exact same thing that we just did through the interface. So now let's take a differential backup. And before we do that, let's run some statements to simulate some activity here in the database. So that just did 2 records into our employees table in the Nugget Demo DB database. So there we go. We added Captain Billy and Steve Ballmer as records there. So now we've got some data. Let's do a differential backup. So same process. Let's just right-click on Nugget Demo DB, head into Tasks, and over to Backup. This time, rather than full, we'll choose differential. And the only other thing we need to do here is remove our destination. Add another one. Let's just browse here back into our Nugget support files, 13 backup. That's where we'll put it. And we'll call this one Nugget Demo DB _. We'll call this def.bak. We'll hit OK. Hit OK one more time. Everything else looks good. Options look good. And we'll hit OK. So that'll do a differential backup. Now let's head into our directory and check it out. We have some changes. So you can see the differential took only the changes, not the entire database, like the full backup did. As far as the Transact SQL goes, it looks very similar to a full backup. The only difference is we have the differential switch on the end of it. That's it. Otherwise, it's very similar to taking full backups. Now, what about transaction log backups? Let's do this. Let's simulate some more activity. Let's add 1,000 random records here to our sales table. So we'll hit execute. There we go. We've got 1,000 records in there. And now let's take a transaction log backup manually. So I'm going to right click on the database, head into tasks, back up one more time. This time we're going to choose transaction log. Let's remove and add a new device here, pointing back into our support files, backup folder. Oop, not that one. Backup. There we go. And let's just do the same thing. Nugget Demo DB _log.trn. All right, standing for transaction, obviously. So we'll hit OK there, hit OK there. And let's look at the 2 options here for transaction log. The first one, and by default, we're going to truncate the log. So anytime you do a transaction log, it's going to truncate anything that it backs up. So it's going to leave the active portion of the log alone. That's going to stay there. But anything that was hardened to disks is going to be truncated because it's going to be backed up and moved over into our backup here. Now, the backup of the tail log and leave the database in a restoring state. This is for a good example of this is if the database crashes or the server crashes or you're trying to recover from something that happened to the database. What you can do is a tail log backup will actually back up the active portion of the transaction log. So this will come into play if you're really trying to get your database back to the state that it was in prior to it crashing. You'll have transaction log backups, hopefully, that'll get you up to the point where everything that was committed is in the transaction log backup, and then you could attempt to do this to get the rest of the transaction log, all the active part. So doing this will give us a transaction log backup with all the changes that we ran in our script here that should be in the transaction log. So if we hit OK, that'll back up the transaction log. Now we can look at the transaction log, and we've added quite a bit of data to it, so you can see it's pretty big right now. But there it is. So if we wanted to reconstruct this on another server, or maybe even on this server, if we had something bad happen and we needed to restore it, we would first restore our full backup, which would get us to the point that we were before all this activity took place. So right when we were here and we did our first backup. Then we would restore our differential, which would get us our employee records back. And then we would restore our transaction log, which would get us those 1,000 sales back. We could even restore to a specific point in time because we have all the pieces of the puzzle here. And that's something we'll look at when we get into the restoration nugget. We'll take a look at how to restore to a specific point in time, how to do that. It's really neat. Now, the next thing I want to show you here is how to automate it, because this is great. Yeah, wonderful. We can do manual backups all day long, but how about automating your entire strategy? Because that's really going to be the goal at the end of the day is we want to automate our backup strategy, right? We don't want to be doing this manually every day. And there's a few ways you can do it. You have a little more control over it. If you're good with Transact SQL, you can build your own script, and then you could put this script inside of a job in SQL Agent, and it'll run every night or whenever you want to do your backups. So here's one way to do it, and it's really just all about dynamically naming your file names. If you want them all in separate directories, spread out, that kind of thing. So I made a little script here that'll do a full database backup using a dynamic file name that'll append the date to it. All right, and this will do a full backup. So you'll need one of these for each type of backup you're going to do, and then schedule them in SQL Agent appropriately. So if Transact SQL isn't your thing, or you want a simple, quick way of doing it, we can use a maintenance plan. So if you head down into the management node, we have this maintenance plan node. And this is really cool, actually. If we were to right-click and choose New Maintenance Plan, it'll open up a designer here with a very, very lightweight version of SSIS, where it'll give us a toolbox full of just standard maintenance tasks like doing things like working with and backing up and rebuilding your indexes, working with your database files, and doing backups and such. I'll show you that designer after we use the wizard, because we're going to need to go in there to modify the schedules for all of our backup types. So let's just choose Maintenance Plan Wizard. So it'll take us through a quick wizard here. You can see here some of the common things you can do with it. We're going to do the database backup part of it. So let's hit next. Let's give it a name. Let's just call this, not that. How about backup strat? If I can spell here. There we go. Almost. There are backup strat. That's right. And we can give it a description, tell it what to run as. And because we're going to have 3 separate tasks, one for each backup type, we're going to want to put these on separate schedules. So make sure we do that. We'll choose next. And now because we have SQL Server Agent set up as master and target servers, we can push this plan and the jobs that this plan is going to create over to our other servers, which could be a nice time-saving feature if you have the same backup strategy across your instances. We'll just keep this local for now and choose next. And here are the tasks we want to do. So here are all the common tasks. We're going to choose backup, backup, and backup, full differential, transaction log, and choose next. You can also choose the order in which they execute. We'll choose next. And that order, by the way, is kind of irrelevant for us because we're going to put these all on separate schedules anyway. But the first thing we need to define is our full task. And then the very first thing we need to define is what databases do we want to back up with our full task. So this is kind of neat, too, that you can cover all of your databases. So we can do all databases, just system databases, just user databases, or mix and match and do whatever you want. So we're going to choose just do Nugget Demo DB, and we'll hit OK. And now all the standard database options we looked at. And also, if you want to spread it across one or more files, you can put them in here. Or you can have SQL Server, or the maintenance plan in this case, do it for us and name them for us. So we're going to create a backup file for all the databases we chose, which is only one. We'll have it create a subdirectory, and you can see it'll auto-name them for us. We don't really have anything to do with the name here. So let's just put this inside of our backup directory here in our support files. So it'll create a subdirectory for this Nugget Demo DB database and auto-name the file for us. You can also verify, specify compression. We're good here, so we'll choose next. And now let's specify our differential. So we'll just do the same thing real quick. Everything looks good. Create a backup directory. We'll browse into support files, backup. All right, everything looks good here. And the last one's going to be our transaction log. Same exact thing. Directory. And we'll browse here into our support files folder. All right, so that's all there is to it. So we set up all 3. You can also have it save this information to a report or email a report whenever the maintenance plan kicks off. That's kind of handy. so we know when things happen. But we'll choose next. Here's a summary, and now it'll actually create the plan, and we're done. Now what? Well, let's open up our backup strategy, our maintenance plan, and I'll show you what it looks like here in the designer. You can just right click and choose modify or double click on it. That'll open up the designer here. And we also need to modify the schedule because we didn't do that. Right now, they're going to execute in order on whenever SQL Server wants. It looks like it didn't really ask us for a time. So one thing you can do here is whatever you click on, it's going to show us the plan, the actual task below. So here's the task. All right. So if you're good with SSIS or anything else, you can add other tasks in here and create kind of a flow of tasks, standard SSIS stuff. But the only thing we really need to do with this plan is specify the schedule for each task. So that's what this button does for us. We can click on this, and here is the schedule. So you can also give these a name, by the way, because it just names them subplan underscore 1, 2, 3, so on and so forth. So we'll just call this full, and this is just naming the schedule. I'll show you where you can find it. But for our full backup, we want it weekly, Sundays at midnight. Perfect. So the default's fine here. We'll choose OK. And now our second one is going to be our differential backup. So we'll just call this diff. This one we want to run daily. We'll call it daily at midnight. Perfect. So we'll say OK here. And then our third one, our transaction log. So let's just call this log. We want to run daily occurs every, let's say, how about 30 minutes? So this one will run every 30 minutes throughout the day. Perfect. So we'll hit OK. And that's it. We've set up all of our schedules in here. So now we can just save our maintenance plan, and it's ready to go. Now, what that did, by the way, is if we look at our local jobs, oh, here they are right down here at the bottom. Subplan 1, 2, and 3. In fact, if we just go into this, let me just double click on it, get in here. Here's our schedule. So that's all we renamed here was a schedule. So you might want to rename the actual jobs as well. So, if you have any other DBAs out there, even yourself, you know what they do. But that's it. So that's how to create a maintenance plan, a great way to automate your backup strategy. And I'll just let this go. We'll come back in the restoring nugget and take a look at what it did and do some restores off it. Now let's move on to file group backup. So we'll open up our file group script here. And the first thing we're going to do is we're going to add a file group to our Nugget Demo DB. Now we already have a ton of file groups when we created this database. In fact, here, if we right click and choose properties and head into our file groups, we have a data, a data2, and an index. And if we look at the specific files, we've got files spread all over the place. So what we're going to do is we're going to say that we're going to create a file group called old data. And we're going to put all of our archive data, that data that doesn't change very often, if at all, into the file group. So we'll create a table then on this specific file group. All right, so let's do that. What we're going to do is just switch to master. We'll add a file group called old data. All right, looks good. Got that in there. Then we're going to alter our Nugget Demo DB and add a file associated with that file group. All right, so that looks good. And then the only other thing we're going to do here is just add a table called sales underscore archive on that old data file group in our Nugget Demo DB. So let's execute that as well. So what that did is if we go back into the properties for our database here and head into our file groups, we now have a file group called old data. We have a file that's attached to our old data file group. And now we have a table in our Nugget Demo DB called sales archive that is going to write its data to the file group. And since we only have one file in that file group, it's going to write all of its data to that one file. So that's really going to be the first step in doing file group backups, is ensuring that your database structure supports it and that it has its file group set up and its files set up appropriately. And by the way, it's not hard to redesign a database to do that. Even if you have a lot of data in it, you can create file groups and then move your objects to those specific file groups and the data within them, especially since most tables will have clustered indexes. It's just a matter of rebuilding your clustered index and pointing it to a new file group. That'll move all the data over to that file group as well. So this strategy really is for large databases. So if you're going to be dealing with databases that are massive in size, then you'll want to get granular, because that's all we're doing is we're just getting a little more granular on our backup strategy. Instead of having a full of the entire thing, a differential of the entire thing, and a transaction log of the entire thing, we're splicing it up. And in fact, let me show you how this works. Let's right click on our Nugget Demo DB, head into tasks, go into backup. And now if we were to do a full backup, say, rather than the whole database, we just want to do a full backup of specific file groups. Now we could say, you know what, our primary file group is important. We want to do that once a week. Same with our data and our indexes and our data too. but not our old data. We'll save that one. That's going to be something that old archive data that makes up 80% of our database is going to change so rarely that we'll only need to do differentials or maybe even a full on it every few months. So maybe you'll do a full backup every 3 months and a differential every 3 weeks or every month or something, something around that. It's all going to depend on your database and knowing your database. So that's all you would need to do. That's really the only difference in the interfaces rather than the entire database, specific files and file groups. Now in Transact SQL, just to give you kind of an idea here, I've got two full backups. One for our archive data, we can say once a month. And the only difference here in Transact SQL is specifying the file group equals and then the name of your file group. So we've got two full strategies here within this database. One for backing up that archive data file group and one for backing up everything else. Again, the regular full backup with all of our read-write data, we could do once a week, where archive data, we could do once a month or even longer if we wanted to. But again, to do multiple file groups, just specify your file groups using a comma and the same file group keyword. So other than that, there's really not a lot of difference here than doing full backup. It's just, again, we're getting a little more granular because we're doing it at the file group level, and it's all going to revolve around the design of your database. So with file group backups, compression, and a good backup strategy, we'll be the ones laughing at those terabyte databases. All right, let's move on to copy-only backups. So what we're going to do here is I'm going to give you a perfect situation of how copy-only backups, what copy-only backups do for us. And I'm going to do it through full backups and differential backups. Transaction log backups, really, you don't have to worry about. No one's just going to come in the middle of the day and take a transaction log backup. But developers love to ninja their full backups, take them into their test environments, and then delete their full backups when they're done with them. And this will really come into play if you have a strategy that uses differential backups. Because remember, differential backups always use the most recent full backup as their base. So let's try this. Let's say we have a backup strategy that does a full backup, once a week, and then differentials maybe twice a day. All right, so let's use that as our premise here. So I'm going to go ahead and just take a full backup of our NuGet demo DB. It's going to go into the copy-only directory I made, and there we go. So there's full backup number one. In fact, if we switch over and go into our copy-only directory, here it is, full backup number one. All right, so that's good. That's intact. Everything's fine. Now a day goes by, say we're in the next day, and it's time for our differential to kick off. And let's also just simulate, say users are in there putting all their data and doing their thing. Great. Oh, and we need to switch here to the NuGet demo DB for this statement to work. All right, so we simulate some activity. Excellent. People are doing their job, doing work. Now, it's the middle of the day. Our differential kicks off. Perfect. Differential happened. All right, and there it is. We've got data in there. Everything looks good. So right now, everything is fine. Simulate some more activity. Let's say we're at the end of the day. Our second differential kicks off. Perfect. So still, everything's fine. No problem. We could recover. No problem at this point. More activity goes on. Now, let's say the next morning, some sneaky ninja developer comes along and says, hey, I need a backup. So I'm going to do a backup. So they do a backup. Great. Their backup works. They take it. They go do their thing. The developer's happy. Now, as a DBA, we come along. Everything's fine. And now let's say more activity happens. All right, more activity, more activity. And now backup number 3 kicks off. Our differential number 3 kicks off. Perfect. So right now, unknowingly to us, everything's fine. But let's say something happened. Something bad happened, and we need to restore the database back to, let's say here, we didn't want to lose any data, so what we would do, again, unbeknownst to us, everything's fine. What we would do is this doesn't exist to us. This fold doesn't exist. We don't know this exists. This is the one that the developer took and disappeared to us, so that doesn't exist. These are the ones that we know exist, and they're sitting in our automated backup directory. So we restore full number 1, restore diff number 1, fine, everything's working great. Diff number 2, fine, everything's working great. Diff number 3, restore, we get an error. We get an error that's saying this differential doesn't belong to this full backup. Sorry, you can't restore. So we just lost all the day's work, and we don't know why. Well, come to find out, Mr. Developer admits that they took a full backup, and they broke our differential chain. So if the developer, or if we didn't give the developer access and we made them come ask us to do the full backup for them, we would have did this. We would have, on that second full backup, did a copy only. In a copy only, would have left our differential chain alone, and differential number 3 would have worked great because it still would have been based off the very first full one that we did. So that's why copy only backup exists, and that's their whole purpose in life is to make us in our lives as DBAs easier. So when those full backups occur, if we do have a differential strategy, that chain won't get broken. All right, let's take a quick peek here at system databases and how to work with them. And there's 4 system databases: master, MSDB, model, and tempdb. You notice tempdb isn't listed. You don't have to worry about backing up tempdb because it gets recreated every time SQL Server is restarted, and it's temporary. So don't worry about that one. The big ones you're going to want to worry about here are master and MSDB. And model if you use it as a template and you make changes in it. So the master database, you'll want to put this on a nightly backup. Back it up every night just to be safe. All of your configuration options across the instance and across all your databases are stored in the master database. So it's important if you want to reconstruct your instance to have your master database backed up. Or if it becomes corrupted in any way, then you're not going to be able to do anything in your instance and you'll want to restore the most recent backup. So that's an important one. MSDB is important, especially if you use SQL Server Agent, because Agent stores all of its job, all of its scheduling, everything you can think of surrounding SQL Agent is stored in the MSDB database, along with a lot of other things here related to your management area. So back up MSDB every night as well, especially if SQL Agent is heavily used. If you don't use it or you don't use it often, then you could probably get away with once a week. And then again here, model, you could probably leave on a manual, just back it up every now and then. Anytime you make a change or somebody makes a change to the model database, you may want to back it up manually. And by the way, you don't have to worry about transaction logs with master and MSDB because it's managed for us since it's in the simple recovery model. So both of these use simple recovery models, meaning the transaction log gets truncated every time SQL Server hits a checkpoint. And every time it hits a checkpoint, it writes all those dirty data pages to disk and then truncates any of those committed transactions. The model database is user configurable, by the way. And where you can find that, and I know I've showed you this in previous nuggets, but just for completeness, if you right click on a database, go into properties, go into options, here's a recovery model. So full, again, means that we're in control of truncating that transaction log. You'll want transaction log backups to keep your transaction log in check. And then simple means SQL Server is going to truncate the log every time it hits a checkpoint, so we won't have to do, and you won't even be able to do transaction log backups in the simple recovery model because there's no point. You won't be able to recover from them anyway since it's getting truncated every checkpoint. All right, so in this DBT Nugget, we got familiar with implementing a backup strategy. We started off with getting familiar with all the backup types and the different strategies we could use by mixing those types together. So we got familiar with what a full backup is, a differential backup, a transaction log backup, your recovery models, and we even talked about some of the factors that'll affect the kind of backup strategy you come up with. From there, we jumped over to the Virtual Nugget Lab and got familiar with how to do backups. We started with the interface and saw how we could do full differential transaction log backups using the interface, got familiar with some options, took a look at how to do it in Transact SQL, and then how to automate our backup strategy using a maintenance plan. We then got familiar with how to do file group backups and how they're great for backing up extremely large databases. We also got familiar with how to do copy-only backups and how they can help keep us sane by ensuring anybody else that does a backup won't mess up our differential backup chain. And at the end here, we'll take a look at how to backup and when and why to backup system databases. I hope this has been informative for you, and I thank you for viewing.